Okay, so you should be seeing the review now.
Yes.
So we start out with some factoring once again, but this time we're factoring in order to solve an equation. So the key thing to remember is that it has to equal 0 on one side, which it already does here. And then we only have two terms. And then the first thing you always want to do is look for the GCF. So do you see a GCF in number 1?
Yes.
Yes, what is it?
It would be X.
Good. So if we factor that out, what does that leave us with?
X minus 1.
Good. Then we use that zero product property, which says that if two numbers multiply together to equal 0, one of the numbers has to be 0, because if not, there's no way you're ever going to equal 0. So then that tells us that either X equals 0 or X minus 1 equals 0, which gives us a solution of 1. So our two solutions are 0 and 1. Okay, so what would be the first step for number 2?
So you'd have to set number 2 to 0
Mm-hmm.
by subtracting the 32 from both sides.
Perfect. And then this time, since we have 3 terms, we're going to have to factor. But this is an example where we can do that quick factoring that I was mentioning last time, because it's just an x squared. There's not a coefficient in front. So what are two numbers that multiply to negative 32, but add up to negative 4?
That's an 8 and a 4.
And then what would the signs be?
Negative 8, positive 4.
Very good. That's how it factors. So then what solutions does that give us?
Positive 8 and a negative 4.
Good. Perfect. How about number 3? What do we have to do first in number 3?
With that one, you would still have to set that to 0, right?
Correct. So I know it's tempting. Sometimes people say, well, it's already written like in factored form. So I can just say like, oh, x minus 1 equals 4x and x plus 3 equals 4x, but that doesn't work. That property only works for 0. It doesn't work for other numbers, because for other numbers, you don't have to use the number itself. So for example, the number 8, if I said, can you give me two numbers that multiply to 8? You could say 2 times 4, right? So to equal 8, one of the factors doesn't have to be 8, right? That property only holds true for 0. So the first thing you actually need to do here then is to FOIL this out and then move the 4x over, and then you'll be able to factor, because it'll then equal 0.
Yeah.
Okay, good. So we're going to FOIL first. So what's x times x?
It'd be x squared.
And then keep going.
Plus 3x.
Good.
Minus x. Minus 3.
And then that all equals 4x on the other side. Running into the last problem a little bit. Okay, so then we want to combine like terms. So 3x minus x is going to give us 2x. And then we can move that 4x over to the other side, right? Because we want to have it equal to 0. So I'll go over here. So now I have x squared minus 2x minus 3 equals 0.
And then you'd have to factor that out, right?
Exactly. So how would that factor?
You do a 3 and a 1. So it'd be a negative 3, positive 1.
Very good.
And then you would get x is a positive 3 and x is a negative 1.
Very good. Nice job. So what would you do for number 4?
So I'd get rid of the parentheses. So distribute the x.
Which gives us
9x squared minus 2x.
Mhm.
And then set it to 0. So subtract the 11 from both sides.
Very good.
And then I guess you'd factor that out, right? So
What factoring method do you want to use?
the trial and error.
I thought you were going to say that because I know that's your preferred method. I remember that from last time.
Yeah.
Okay, so let's try. Hopefully we don't err, but that's okay if we do, because that's how the method works, right? Try, it doesn't work, you try again, and eventually it works. Okay, so what do you want to try?
I'm just gonna go with the 9x.
Okay, so 9x and x. Okay.
But 11 is prime, right? So so nothing is really going to factor this out.
Well, what numbers multiply to 11?
Nothing. It's just 11 times 1.
Yeah. So you can use that.
Okay.
So let's put an 11 and a 1.
Like, oh, okay. Never mind. I see it. If you did
And
it
then
that
how do you want to try the signs?
All right. So it'd be a negative 11 and a positive 1.
Good, because if you FOIL that out, which you can do off to the side, I'll do it right above it, you get 9x squared plus 9x minus 11x minus 11, which does combine back to the original problem. Very good.
All right.
So then we use the zero product property one more time. So what solutions does it give us this time?
So you get a negative 11 over 9, and you get a negative 1.
Okay, I agree with you about the negative 1, but it should be positive 11 over 9 because you had to add 11 to each side.
Yes, I see that now. Sorry.
Oh, you're fine. Good. Okay, for number 5, what would you do first there?
I would pull out the GCF.
Which is?
An X.
Good. So that leaves us with x squared minus 10x plus 21 inside parentheses. So then how would that factor?
That would be an X minus 7 and an X minus 3. So you would get an X equals 0, an X equals a positive 7, and an X equals a positive 3.
Very, very good. Before you even worked out the problem, what would be a hint that this problem might have 3 solutions? All the other problems we had done so far today had 2 solutions, right? But what would be a hint that this one might have 3?
Because you have 3 variables.
What do you mean by that?
You have the X that you pulled out of it.
Yes, you have the X that you pulled out of it. So then the hint would be that the original polynomial had this X cubed, right? That the biggest exponent was actually a cubed. Whereas in the other problems, it was always just a squared, right? If you go back and look at them, it was always just squared. So that's a hint that you may have more solutions. Now, you don't always know. Sometimes there's a duplicate solution, but there should be 3 solutions there. Some of them could be imaginary, but there should be 3. So Number 6, find the domain of the rational function. When you're dealing with rational functions, what part of the fraction do you care about when you're trying to find the domain?
The denominator.
The denominator, because in general, you're never allowed to divide by what number?
0.
0, right? So that's why the rule here is that you have to take the denominator and figure out what value causes it to be 0, because that's what x is not allowed to equal, because you can't be dividing by 0. So we want to say, okay, the denominator cannot equal 0. So we really don't care about what you have in the numerator. We just want to say the denominator cannot equal 0. So what solution does that give us? X cannot equal what?
X can't equal a negative 7/4.
Good. Perfect. Okay, number 7. Once again, what part of the fraction do we care about?
The denominator, so the x squared minus 9.
And then there's actually a couple ways we could solve this. What's one way we could solve this equation?
You can factor it out.
So how would it factor?
So it'd be x minus 3 and then x plus 3.
So then what solutions would that give you?
It would be a positive 3 and a negative 3.
Exactly. Another way that some people use, even though we technically learn it in the last module, is you could have taken the x squared minus 9 and actually added 9 to both sides, and then used what's called the square root property to take the square root of both sides, which we'll learn about more in the next module, but some people sometimes remember it from earlier math classes. So then that tells you that x, the square root of x squared is just x, cannot equal, and then whenever you take a square root of both sides of the equation, you get plus or minus. So you automatically get the positive and negative 3. So it does still give you both answers. So it's another way to do it, but the factoring method is definitely the method you've learned so far in this course. But they both work. So they're both good. Okay, number 8, simplify the expression. The key thing I want to mention is that you cannot just cancel things out term by term. So you can't just be like, oh, let's look at this and let's look at this and see what cancels. That's not how this works at all. You have to factor numerator and denominator as your first step. And then when things are in factored form, that's when you can cancel things out, just like with a regular fraction. So let's think for a second of the fraction like 6/9. If you break it down into its factors, right? 2 times 3, 3 times 3, we know that you can cancel out the 3s and this becomes 2/3. Right? We're kind of doing that same idea where we're factoring it first, canceling what they have in common, and then reducing. But this doesn't work if you have something like 5 plus 2 over 10 plus 4, you can't just randomly, so let's work this out actually, right? And then I'll show you what people try to do and show you why it doesn't work. What is 5 plus 2?
Oh, 7.
7. And 10 plus 4?
14.
14. So this is really equal to what?
1/2, so 1/2.
1/2 or 1/2, right? Okay, so you can't just randomly be like, oh, let me just cancel things out. Oh, 5 and 10, they go into each other, right? Oh, there's a 1 here, there's a 2 here, 2 and 4. Oh, that's also half. Oh, they go into each other. Great. Okay, I'm gonna just magically do. You can't. That one. I hang on. I actually made that one work accidentally. Okay, let's pretend.
Yeah, I was gonna say that would work.
That one actually worked. That was a bad example on my part. Let's make this a 7 for a second. No, an 8. Then it should not work. Leave it to me to randomly pick a number and make it actually work. Okay, so if it was an 8 for a second, this would be 7 over 18.
Mhm.
Okay, and then that would be a 1 and this would be a 4. This is definitely going to not work, right?
Yeah.
So then it would be 2 over 6, which is 1/3. Leave it to me to find the random case where it works. How do I do that? I don't know. Okay. My first example only worked because they actually were, the bottom was just the top multiplied by 2. So that was
Yeah.
I shouldn't have done that. But okay, now the bottom line is it doesn't work in general. Geez. There I go. Speaking of bad examples.
It's
Okay.
okay.
But you understood the point.
Yes.
You can't do that most of the time. Okay. That's me getting mad at math for a second there. Okay. It is my own fault. Number 8. Back to the original problem. We're not going to do what I just showed, doesn't work. Instead, what we're going to do is factor, right? So what can you factor out of the numerator?
So out of the numerator, we can pull a 2 out.
Good. Let me go back to the drawing board. Okay, we can pull out a 2. Good. Which leaves us with?
An x squared minus 25.
Okay, and then the denominator?
You can pull the 8 out.
Mm-hmm.
So it's x minus 5.
Good. What else can we factor now?
So then we can factor the numerator. So we can do the x minus 5 and the x plus 5.
Good, since that's an example of difference of squares. You really have to know your factoring, right? If you don't know your factoring, this module is rough. Okay.
All right, so you can cross out both of the x minus 5s.
Good, so now that we've fully factored, we're basically doing this step up here, right? Where we're now canceling out what they have in common. So I agree with you, they both have x minus 5. And then what else can we do?
The 2 and the 8 can simplify. So it would be 1 over 4. And then you would bring over the x plus 5 on the top, on the numerator.
So the answer could be x plus 5.
5 over 4.
All over 4. I ignored the 1 because 1 times anything gives you back.
Yeah.
Good. Let's check out number 9. What do we need to do first?
The top, you can break that down into 1 minus m and then 1 plus m. The denominator, you can pull a negative 1 out.
Okay.
And make that a 1 minus m.
Very good.
So then you can cancel out the 1 minus m. And then negative 1 divided by the negative 1 plus m. Would you keep the negative outside the parentheses? Would that be okay?
Negative 1 in your denominator.
Yeah,
right?
But you can divide that. So would that be okay to keep the negative outside? Like just negative parentheses 1 plus m?
It does say simplify. So the answer they give me, they do actually distribute it. So they do actually put the negative 1 minus m. They end up dividing each term by it. What you're saying is equivalent, but because they specifically said simplify, I don't know if they want it, they might want it distributed.
Okay.
But I mean, is it mathematically equivalent to write this? Yes. I'm just not sure.
So I probably would have still got it wrong if I would have left it like that.
I'm not sure. I can't promise you there for sure.
Yeah.
Sorry.
Okay.
Number 10, this is an example where you cannot do what I was talking about earlier, where you can't magically cancel out X, Y's and X's and Y's. That does not work at all. Instead, what we've been doing each time, right, is factor. So we need to factor the numerator, factor the denominator, and then put it all back together and see what can cancel. So I'm almost going to initially treat this like two separate problems, right? So let's first factor the numerator. Since we have 4 terms, there's only one factoring method that we've learned with 4 terms.
Which is the grouping.
Mm-hmm.
So the first 2, you can pull out an x.
Good.
So it'd be 2y plus 9.
Awesome.
The second, you can't pull out anything.
Other than what? I agree it's not anything exciting, but there is something.
The negative?
The negative, and what number? It doesn't really change anything, but you need to have a number there.
Oh, like a -1. Oh, okay, I see what you're saying. All right.
You need to have it there for the next step, right? So for this step, technically the 1 doesn't really do anything, but in the next step, when you're factoring out the 2y plus 9, you need to know what number is there. So we like to write the 1 in when it happens to be -1. Okay, so then what would be the final answer for the numerator in factored form?
It'd be 2y plus 9 and x minus 1.
Perfect. So now we need to do the same process to fully factor the denominator.
So the denominator would be the pull out the x. So it'd be 5y plus 4. And it's the same, you pull out the -1. So it'd be 5y plus 4. So then the denominator would be 5y plus 4. And then the same, the x minus 1.
Good. So now I'm going to write it as a fraction once again. Now it's written in factored form. So now we can cancel out the factors that they have in common. Which is what?
The x minus 1.
Good. So now you have 2y plus 9 over 5y plus 4. Can we cancel out the y's here?
No.
No, because they're part of a sum, right? If they're part of a sum or difference, you can't cancel them out. It would only be if the 9 and 4 weren't there and it was just 2y over 5y, then you could cancel out the y's because they would be just part of that product. But because something's being added or subtracted, you can't do it. Sometimes when I teach this lesson, I actually tell my students that there's 3 steps, even though the 3rd step is kind of silly. So I say you have to factor first, then you cancel, but then I actually say, then you stop, right? Because sometimes students have a habit of going further and canceling things that can't be canceled with the y's here. So that's kind of why I say that, even though it's kind of silly, because like, well, if you don't make that a step, obviously you're just done, but it's like a reminder that don't go too far.
Okay.
Okay, so what's going to be the first step here? Now we're multiplying fractions together, but it still starts with the same first step, which is?
I would say factor them all out.
Factor them all out. Lots and lots of factoring. Okay, so how would you factor the first numerator?
X minus 6 and x plus 6.
And the denominator?
That would be a 6 and a 4, a -6 and a +4.
Then you want to see if there's anything that cancels. It doesn't matter which fraction it's in, as long as it's in the numerator and the denominator, it can be canceled out.
So then both the x minus 6's cancel out, and then the x plus 4. So it's just x plus 6 over x.
This is another example where the x's do not magically cancel out and just give you an answer of 6, right? The x in the numerator is being added, right? Anytime something's being added or subtracted to something else, it doesn't cancel out unless you see the identical thing, right? So the only thing an x plus 4 can cancel out with is another x plus 4, right? It can't cancel out with anything else.
Yeah.
Very, very good. Okay, and we keep going, more factoring. So take a minute, see if you can do all the factoring, and then I'll go over it with you.
Okay.
Okay, so how does that first numerator factor?
All right. So it's z plus 5 and z plus 2.
Good. And then the first denominator?
Z plus 10 and z minus 1.
Perfect. And then the second numerator?
It's z plus 4 and z minus 1.
Good. And the last denominator?
Z plus 4 and z plus 2. I mean, z plus 2 and z plus 2.
There you go. I put little slashes through my Z's because otherwise they look like two.
I do the same. Yeah.
Something. They look like something else. Okay, definitely not the easiest letter to work with. Okay, so what cancels out here?
All right. So the z plus 2 on the numerator and the denominator.
Mhm.
The minus ones cancel out. All right. So then you get the plus 5 and the plus 4 over the plus 10 and the plus 2.
Okay, division is almost the same as multiplication because the first step when you divide is to do what?
You got to factor it first.
You can factor it first, yes, but what division is really the same as doing what?
Well, you got to flip it. And
Yes. So you can think of the KFC, right? The keep flip change is one way to think about it. Or think about it that you're multiplying by the reciprocal. So you keep the first fraction the same. Flip over the second fraction. And then change from division to multiplication. And then you're absolutely right. We need to go ahead and factor. So the first denominator, or the first fraction, excuse me, is already factored. But the second fraction, we still need to factor. So what can we factor out of the numerator?
X plus 3. Wait, on which one?
So
On
I
that,
flipped it.
oh, on the
Right.
second fraction, you can get, you can pull out the 3. So you can
Mhm.
get an x minus 3 inside parentheses. And then on the bottom, you can do a x minus 3 and an x plus 3.
Good. And if you rewrote the numerator twice, that's not a bad idea. So if instead of writing x plus 3 squared, you wrote x plus 3, that could actually
I did,
help you
yeah.
see what to do next. So I realized what you were about to say.
That's why it confused me. I'm like, oh, wait, you already.
I just rewrote it, but that's absolutely a great idea to possibly do that. Okay, so what cancels out here?
The x plus 3s, one of them.
One of them. I'm just going to get rid of the squared and then this one. Yep.
One of the x minus 3.
Good.
So then you have on the top for the numerator, you have 3 times x plus 3 over x minus 3.
Okay, so walk me through what to do in the next problem.
Okay, so that one, I'll go ahead and, I'm going to go ahead and rewrite the first one as x minus 2 and x plus 2
Okay.
over 8x. And then flip the other one, so it'll be 4xy over 2 minus x.
Okay.
So out of the second one, I'm going to pull a -1 to make that an x minus 2.
Good.
And then the x minus 2 and x minus 2 cancels out.
Good.
So then you have the 4xy. Can I go ahead and I can go ahead and cancel out the 4 and the 8 too, right? And break that
Yes.
down before okay.
Mm-hmm.
All right, so then that becomes a 1 over 2.
Mm-hmm.
So 1/2, and then the x's cancel out.
Good.
So then you have a y and an x plus 2 on top. Over a 2 on the bottom, and it's all negative. Did I do that right?
Yep. And you can put the negative out front if you want. Very
Okay.
good. Okay, so now we're all done with the multiplying and dividing. So we're now going to subtract, which is a little bit different because with multiplying and dividing, you're just factoring and canceling things out. But when you're adding or subtracting, you need to have a common denominator. So we are still going to have to do some factoring, but then we're also going to have to often create a common denominator in order to finish the problem. So first thing I want to do here is go ahead and factor the denominators if possible. The first fraction is there's nothing to do, but the second fraction, how could you factor the denominator?
So it'd be the x minus 1 and x plus 1.
Good. So then if we need a common denominator, what is our LCD going to be here?
X minus 1, x plus 1.
Good. So the second fraction already has that, but what is the first fraction missing that it doesn't have in the denominator?
It's missing the x minus 1.
So if we have to multiply the denominator by x minus 1, that means we also have to multiply the numerator by x minus 1, right? Because really you want to multiply the fraction by 1. So whatever you do on the bottom, you have to also do on the top. Okay.
Yep.
So then we can distribute the 2. So what do you get when you distribute the 2?
2x minus 2.
Good. And then we can actually combine it all into one fraction since now we have the same denominator. So just minus x, right? We can lump it all together all over that common denominator that we now have, x minus 1, x plus 1. And these are the same rules we would use, right? If we were dealing with numbers, just like I showed you when we were simplifying earlier, it's the same rules we would use with just numbers. So I mean, if we were doing like 1/2 plus 1/3, right? The way to do it would be get a common denominator of 6. So you'd end up multiplying the first fraction by 3 over 3, the second fraction by 2 over 2, and you would get 3 from the first fraction, 2 from the second fraction. Each of your denominators is now 6, so you keep the denominator the same. And then that would be your answer, right? So we're doing the same process just with variables.
Okay.
Okay, so now we do have 2x minus x. What does that give us?
X.
X. So then that ends up being our answer, x minus 2 over x minus 1 times x plus 1. Okay, so what do we need to do first in number 16? Oh, you do have to check at the end, by the way, to make sure nothing simplifies or nothing cancels out, but nothing does here, but it could happen in some of the problems where there is something that needs to be canceled out. Okay, so what would you do first here?
I would factor the squared.
What do you mean?
Well, you'd find the LCD,
Mm-hmm.
but that one's squared, so the LCD would be that the x plus 8 twice.
Yes. So you could write it as squared, or you could absolutely write it twice, either way. So the second fraction's already set. What does the first fraction need in the denominator?
It needs another x plus 8.
Good. And then whatever you do in the bottom, you also have to do in the
top, the numerator.
Top, right? So what is x plus 8 times 1?
X plus 8.
Mm-hmm. And then from the next fraction, you have a minus 4, right?
Mm-hmm.
All over your common denominator, x plus 8 squared. So what is x plus 8 minus 4?
X plus 4.
Mm-hmm. Good. I think there's one more of these. Yes. What would your LCD be here?
B minus 2. Would it be a 7v and a v minus 2?
Exactly. You have to include all of it. Very good. So what is the first fraction missing that it needs to have in the denominator?
V minus 2.
Mm-hmm. And then what is the second fraction missing that it needs in the denominator?
7v.
Good. Okay, so what is 5 times v minus 2?
It'd be 5v minus 10.
Good. Plus what?
Plus 14v.
Mm-hmm. All over
the 7v times v minus 2.
Okay, and then last but not least, if we combine like terms, what do we get?
19v minus 10.
Mm-hmm. All over the denominator. Okay. Number 18, I'm going to end up comparing and contrasting number 18 with the problems we just did, because the first step seems kind of similar, but it's actually quite different all at the same time. So we do need to factor and figure out the LCD, but then the way we use the LCD is very different. So how could you factor the second fraction there? The denominator.
The denominator would be the x minus 1 and x plus 1.
Good. So what is the LCD here in this problem?
The x minus 1, x plus 1.
Good. So far it feels very similar to what we just did in the last few problems, right?
Mm-hmm.
But here's where I'm going to change things up a little bit. Instead of multiplying the first fraction by what's missing, which you can do, but you don't have to, because now you're dealing with an equation, which is very different. The other problems we just did, the last 3 problems before this one, were all expressions because they did not have an equal sign in the original problem, right? If you look back at the original problem for 17, for example, is there an equal sign? No, it just has a plus sign, right?
Yeah.
So it's just being added. And if you look back at 15 and 16, they were both just being subtracted, but there was no equal sign. Okay, do you see what I'm getting at? So 15, 16, and 17 are all expressions. When you're dealing with expressions, once you find the LCD, you have to combine the two fractions so that you have just one fraction, and that one fraction is your final answer. Okay, but when you're dealing with an equation, which means you had an equal sign in the original problem, then you can actually use the LCD a little bit differently. You can actually multiply the LCD to each term. So some people get confused and try to do this method with expressions, and it doesn't work. It only works with equations. With expressions, it doesn't work because there's not another side. So the reason this works for equations is because whatever you do to one side, you're doing to the other side to keep it balanced. But with expressions, there's no other side, so you're not balancing it, you're actually changing the problem. So here, what cancels out?
So the x plus 1 cancels out on the first one. So you just have the x minus 1. And it'll just be plus 2 equals x minus 1, x plus 1.
Then notice they're actually being multiplied. So you're going to have to FOIL here. So it gets a little messy, but it is correct. So this, of course, is x plus 1, right? Minus 1 plus 2 is plus 1 equals, what do you get when you FOIL there?
The x squared minus 1.
Yeah, if you cancel out the middle terms because you have a minus x plus x. Good.
Yeah.
Now, what do you have to do? This is a quadratic equation. This is actually a lot like, at this stage, a lot like what we started with at the beginning of this review.
So we got to set it to 0.
Very good.
So I would subtract the 1 and the x from the one side, the positive 1 and x. Yeah.
That way you have an x squared. Yep, I understand what you're doing there. So the x squared and the x don't combine, right? So now you have 0 on one side equals x squared minus x, and then negative 1 minus 1 is negative 2. So then how would that factor?
You would have a 2 and a 1. So it'd be a negative 2 and a positive 1. So then the outcome would be x equals a positive 2 and x equals a negative 1.
Yes, but unfortunately there is one more step, which is that for these problems, you may get an extraneous solution. So you have to check it and make sure it works. So you have to make sure it does not cause your denominator to equal 0, right? Because remember we did earlier that the domain cannot include any x values that cause your denominator to equal 0. So if you plug 2 back in, you're fine, right? Because your first denominator would be 3 and your second denominator would also be 3. So 2 definitely works. But what happens if you plug in negative 1?
You get a 0.
You get 0 right away. So that means negative 1 is an extraneous solution. So therefore your only answer is 2. Okay. Now let's try another one. So what would you like to do first here?
So we have to multiply by y plus 21. So then it becomes 7y plus 21 plus 8y, or equals 8y plus, let me see, 21 times 8, 168.
Excellent. Great job. So you identified the LCD and then multiplied it to every term. And then now what? How would you finish out the problem?
I would just solve for y.
So now we have a linear equation. So gather all the y's on one side and all the constants on the other. So how do you want to do it?
Subtract the 21 from both sides.
Okay.
So that would equal 147. I would subtract the 8y after that. So it's a negative 147.
Good. Divide both sides by -1 and you get -1. Not very satisfying, right?
No.
But it is the answer. That is the challenging part. Sometimes you get an answer and you're like, really? The last time the answer was 2. That felt pretty good. -147, pretty large, but
It kind
correct.
of makes you question it too. It's
It
like,
does. Now you can always check it. It'll take a little bit of effort, but could you plug in -147 on the left side, work it all the way out and confirm that it equals 8? Yes. Is that going to take you a minute or two? Probably. But if you have some extra time, by all means, go for it.
Okay.
Especially if you're a fast test taker, right? If you're not, make sure you do all the problems first and then maybe check your answers.
Yeah, that's what I do.
Because I would never want you to not finish a test because you spent 5 minutes checking an answer. You know? So other than, you do have to make sure still that the denominator doesn't equal 0, but that you can check pretty quickly without checking the whole answer.
Yeah.
Okay. Number 20. Oh, this is going to be a fun one. I can tell already. And by the way, yes, code, my students would always laugh at me because they're saying, if you say fun, that means like hard or challenging or difficult. I'm like, yeah, but why not call it fun?
Right.
Why not? Maybe it'll make you enjoy it a little bit more. Maybe. I can hope, right? So what would you do here?
Pull out the GCF in all of them.
Yes, very good. So what's the GCF in the first fraction?
3.
In the denominator, that is, of course. Is
Yeah.
what we're focusing on. Good. And then the second fraction?
Is 4.
Only one bit of good news. What's the good news at least? Once you pull out the GCF, what happens?
What do you mean what happened? Oh, you have your LCD?
Yeah, your LCD at least is helpful in the sense that they're all y plus 2s, right?
Yeah.
So you don't have to use like a bunch of different ones being multiplied together. And then what number?
It would be 12 times
Good.
y plus 2.
Yep. So then what are we going to do with that?
You're going to multiply that by every single one of them.
Exactly. Since we have an equation, we can go ahead and multiply that to every single one. Okay, so what happens now?
So the y plus 2 will cancel out, but I can simplify the 12 and before multiplying it by the 3y, right?
Yes,
So then that would be a 4 times the 3y.
exactly.
Okay.
Divided by 3 is 4, and then 3y times 4 is...
So that would be a 12y.
Good.
Okay, so plus, so then you would cancel out the y plus 2, and that would be a 3 times 7, so it'd be 21y minus 6.
Very good.
And then on the last one, that would be a 72y plus a 72.
Very good.
And then I would combine the like terms. So 32y minus 6.
I think it's 33, right?
Oh, my bad. Yeah, 33y minus 6 equals 72y plus 72. So then
Good.
I would add the 6 to both sides. I would subtract the 72y.
So what does that give you?
Negative 39y. And then divide it, the negative 39. So it'd be 78 over 39.
which actually divides evenly.
Let me see. 2. -2.
Mhm. So what's your answer?
It doesn't work out. It's no solution.
Why is it no solution?
Oh, wait, hold on. Never mind. Oh,
You're
it is no
correct.
solution. I was right. Never mind.
Mhm.
Because when you plug that 2 back in, it's a 0.
It actually causes all of your denominators to be 0, but you only, as long as it causes one of them to be 0, it doesn't work. But since it causes all of them to be 0, definitely doesn't work. So no
Do
solution.
all that work, and it's no
I
solution.
know. Sometimes it's frustrating, right? It's like I just used up a whole piece of paper to figure out there was no solution. And so that's what happens if you get an answer, just one answer that doesn't work, it ends up being no solution. But as you saw in the earlier problem, if you get 2 answers, it could be that like one works and one doesn't. So that's why we only entered 1. It could have been that none of them worked in that earlier problem, or it could have been that they both worked. Anything is possible. So you always have to check all the solutions when you're dealing with a rational equation, which is an equation with variables in the denominator. Okay. So now what we're going to do is solve a few literal equations, which are equations that have a bunch of variables, but not as many numbers. So your solution is going to involve variables, right? And I think we did a few of these in an earlier module, but now we're doing some that have fractions. We're going to use the same rules that we've been using, except now our answer is just going to have more variables than numbers.
Okay.
So to solve for W, that means we want to get W by itself. So we're going to use the same strategy we've been doing to clear out the fractions, which is multiplying by the LCD, right? So what is the LCD here?
H squared.
H squared. So we're going to multiply by H squared on both sides. So it's really the same thing we've been doing, just with all variables now. So now these H squareds cancel. So now you have A times H squared equals 770 W. So how can we get the W by itself?
You divide the 770 by both sides.
Good. And then that's our answer. W equals A H squared over 770. And I think I talked to you guys before about how it matters whether you use capital letters or lowercase letters. So make sure you use a capital A and a lowercase h when you type that in.
Okay.
Or else they will mark it wrong. I have seen that happen.
All right.
Okay. So number 22, solve for C. The first step is typically to get rid of the fraction. So how could we get rid of the fraction here?
You multiply the C by both sides,
Mm-hmm.
or by everything.
All the terms, yep. So what does that give us?
So you got PC equals SC plus KC.
Okay, be very careful at the end there. The C's cancel.
Oh, they
out.
cancel.
So it's just plus
K.
K. Okay. Now this is a little bit tricky because we're solving for C, and there are 2 terms that have C, right? There's a PC and an SC. So what do we need to do there?
I don't know. If I subtract.
Subtract what? You might be onto something.
I was gonna say no. I was gonna say subtract the K, but that won't really matter. It still keeps the C signs.
So I want to point out something. If you cannot do this, because sometimes students try to do this, so sometimes I show you what not to do. I mean, legally, mathematically, can you divide by P? Yes. But if you do that, yes, you get C over here, right? But the problem is you have a C in
It's
your
still
answer,
there. Yeah.
right? So when you solve for C, you can't have a C on the other side. So that's why that doesn't work, in case you thought of that. You can't solve for C and then still have a C there. So what you actually want to do, the trick is to get all the terms with C in it on the same side. So you actually want to subtract the SC from both
Okay.
sides as your next step. And then how can you separate the C here? There's something we've learned about a lot, that we've talked about a lot today even, that can help you kind of pull that C out.
Oh, you factor it out. I remember
Yes.
doing these now.
Mhm. Factor out the C,
Okay.
which leaves you with what?
So it would be C times P minus S.
Yes. And now how could you get the C by itself?
And then you can divide it.
Exactly, divide by the P minus S. And that would be your answer. C equals K over P minus S, all capital letters. So that is the trick. If a variable appears in multiple terms, gather all those terms on the same side so that you can factor out the variable, which will help you to get it completely by itself on one side of the equation. Okay, so let's try number 23. What would you do first there?
I would multiply by the LCD.
Mm-hmm.
So that would be 4AX.
Mm-hmm.
So then that would become 4X plus AX equals 4A.
I agree with you. Good. Now we're
And I would
solving for
factor.
X. Yay! Okay, good. Factor out the X, which leaves you with?
4 plus A in parentheses.
Good. And then?
And then you would divide the X.
Divide by what?
Oh, the 4A. Right? Did I do that right?
So you want to get the X by itself, so you would divide by what? I don't think I heard you say the right thing yet, but.
I would divide by the X, right? Oh no, the 4A. Divide by the 4A.
So the 4A is over here. You don't want to divide by it.
The 4
4
plus A.
There you go.
That's what I meant.
That's what I was confused about. I was like, you might have been thinking it right and then not saying the plus. I don't know. I wasn't sure. But you want to divide by 4 plus A so that the X is now by itself on the left side. So your answer would be 4A over 4 plus A. Why can't you cancel out the 4s or the A's there? Why is that your final answer?
Because they're its own term.
Yes, in the denominator, there's a plus sign, so each of them is its own term, so you can't just cancel them out. Good. Good, good, good. Awesome. Okay, so now we're going to solve a proportion. What is the trick to solving a proportion? What's the shortcut you can use?
You can multiply across.
So you can multiply the 6 times what?
The 7x plus 4.
Good. And then you can multiply the 5 times what?
The 9.
Good. Do you know why that works?
No.
You're actually just multiplying by the LCD. So the LCD here would be 5, 7x plus 4, right?
Okay, yes.
If you did it the other way, and I'm not saying you have to do it this way, I just figure you might as well know why you're doing what you're doing. All right, if you did that, the 5s would cancel out, so you would just be multiplying the 6 by the 7x plus 4, and the 7x plus 4s would cancel out, and you would just be multiplying the 9 by 5. So instead of writing out that process every time, we teach you the shortcut that you can just do the cross product. But it really is just based on doing the LCD.
Okay.
So just in case you were curious. Sometimes it helps me to understand why I'm doing something, right? Like, why does this work? So that
Yeah.
gives you the background. Okay. So when you distribute 6, what do you get?
You get 42x plus 24
Equals,
45.
okay. And then what would you do?
You'd subtract the 24.
Mhm. So 42x equals,
21.
good.
And then you would divide the 42.
Mhm.
So it would be 1/2.
Very good. 42 is 21 times 2, so it would reduce down to 1/2. Excellent. So now we're going to do some word problems with rational equations. Isn't this exciting?
No.
At least you're honest, right? That's all I can ask for. Okay. A company found that an experienced surveyor can survey a roadbed in 5 hours. An apprentice surveyor needs 8 hours to survey the same stretch of road. If the two work together, find how long it takes them to complete the job. So in theory, what should happen here? If they work together, what should happen?
You combined.
Yeah, so in theory, is it going to take longer or shorter?
Oh, if they work together,
Mhm.
I think it would take shorter, right?
Exactly. It should take shorter than the faster person, right? Because if the faster person can do it in 5 hours alone, then we know, okay, our answer should be less than 5 hours, right? If the guy helps out. Although I always joke that you never know, sometimes two people get together and it actually slows them down.
That's
right?
true.
Has that ever happened? You try to like study with someone and you spend half the time studying and half the time giggling about nonsense or whatever.
Yeah.
So, I mean, we've all done it, but that's okay. So, okay, we have an experienced surveyor and an apprentice surveyor. So I'm going to make a chart. You don't have to make a chart, but if it helps you, I definitely recommend it. So the experienced surveyor, the time to complete the job is 5 hours. Okay, the apprentice takes 8 hours. With me so far?
Yeah, hold on 1 second. Someone's at my
Sure.
door.
Go for it. Everything okay? Oh, you're still muted.
It was the neighbor kids.
Okay. Perfect. Okay. So the time complete one job, if it's 5 hours, then the part of the job completed in 1 hour, you're going to do the reciprocal, right? Because if you can do the job in 5 hours, that means in 1 hour, you do 1/5 of the job, right? Because then if in each of those 5 hours, you do 1/5 of the job, then you've done the whole job in 5 hours, right? So to go from the first column to the second column, it's always the reciprocal.
Okay.
Okay, so then if the apprentice can do the whole job in 8 hours, what part of the job can he do in 1 hour?
It would be 1/8 for the
Exactly.
apprentice. Yeah.
Mhm. So then we don't know how long it takes them if they work together. So I'm going to call that X, but then what would be the reciprocal of X?
1/x.
Good. So then this is the equation that we're going to solve to figure out the original solution. So we're going to do 1/5 plus 1/8 equals 1/x. Okay, and then we're going to solve it by doing what we've been doing, finding the LCD. So what would be the LCD here?
It would be 40x.
Good. So we're going to multiply that to every term, which gives us what?
It would be 8x
Mhm.
plus 5x equals 40.
I managed to mute myself. Okay. 8x plus 5x is
14x. Oh,
almost.
13x.
There you go. Divide by 13. By the way, you can leave your answer as an improper fraction, so they will accept this answer. I know if you get it wrong, they tend to show a mixed number as the final answer. So if you got this question wrong, the computer would probably show you this because they would figure out how many times 13 goes into 40 by doing like long division, which would be 3 times, and then the remainder would be 1. So that's where the numerator would come from, but they will accept the improper fraction. You do not have to convert it to a mixed number.
Okay.
Okay. So let's check out the next problem. A lot of blanks to be filled in here. A jogger begins her workout by jogging a distance of 8 miles. She then jogs home at the same speed along a different route that is 12 miles. Her time is 1 hour longer. Find her speed. Okay. Distance, rate, time. Got it. So her rate, if we're using the letter R, her rate is the same going to the park and coming home from the park, right? That's what they tell us in the problem. So our rates are both going to be R. But let's use this. We know that distance equals rate times time. And anytime you're filling out a distance, rate, time column, you're really only filling out 2 of the columns, and then you're using those 2 columns to figure out the 3rd column. So in other words, back in the day, in I think the first module, we would fill in the rate and the time, and then we would multiply them together to fill in the distance column, if you recall doing that. So now this time what we've done is we've filled in the distance and rate column, and we're going to use those to fill in the time column. So we have to solve for time here. So if you divide both sides by rate, you see that time equals distance divided by rate. So the distance was 8 for the trip to the park. The rate was R. So the time would then be 8 over R. Okay. And then how would you fill out the time for the return trip?
It would be 12 over R.
Good. Okay, then the key thing that's going to help us write the equation is that the return trip is 1 hour longer. So what equation could you come up with here?
1 plus x.
1 plus what? So we're going to be using this column.
1 plus r.
So we're not going to just use R. We're going to, the times are 8 over R and 12 over R. So that's what we're going to be using. So let's think about it for a second. Okay, if it says, let's just think about it in terms of words. If the return trip is 1 hour longer than the trip to the park, are you going to put 1 plus trip to the park equals return trip? Or are you going to put 1 plus return trip equals trip to the park? Which one? Which way?
It would be the 1 plus the return trip. Right?
Okay, so you're saying 1 plus the return, the time for the return trip. I'm leaving that out, but assuming that's understood, equals the time for the trip. Now go back and read your sentence and see if that makes sense. It says the return trip is 1 hour longer. So give me some actual numbers. Let's say guess how long it takes her to get to the park. Just pick a random number. Just pick it. It doesn't have to be right. Just pick your favorite number. It can be 147. It can be your number from earlier. It doesn't
24.
matter. 24. Okay. The number doesn't have to make sense. Okay.
Okay.
Let's say that's how long it took her to go to the park. if her return trip is an hour longer, how long would it be?
Oh, it'd be 25.
Okay, so does 1 plus 25 equal 24?
Oh, no.
No, so it's actually the other way around, right? So the key thing here is you actually have to do one, if it's an hour longer, it means that you have to actually add an hour to the other time to equal its time. So 1 plus time for trip to park is going to equal the time for the return trip. Because now if you pretend that it takes 24 hours to get to the park, which obviously is ridiculous, then if you add 1, we'll pretend it's minutes or something, who knows, then it would equal 25. It would actually work.
Okay.
Okay, so now you have to plug in these values. So instead of writing time for trip to park, you're really just going to plug in the 8 over R, right? Because that represents the time for the trip to the park. And then the time for the return trip was 12 over R. I'm just borrowing the information from the chart.
Okay.
Okay. This is definitely a very tricky equation to set up. So
Yeah.
you're
I
not
struggle
alone
with
going.
word problems anyways, so.
Yeah, word problems are tough to set up anyways, and this one is not completely like straightforward, so it makes it even harder. Like these ones, the one we just did with the work, once you kind of figure out a pattern, they kind of all flow the same way, right?
Yeah.
But this one's definitely a little tricky. Okay, not too bad to solve though, once you finally have an equation. So how would you solve it?
You'd multiply by the LCD.
Which is?
R.
So what does that give us once you do that?
So you'd have R plus 8 equals 12.
There you go. So R would equal?
R would equal 4.
4. And then what would be the units for the speed? Would it be miles, hours, or miles per hour?
I don't know. I can't see the word problem. Is it miles per hour?
Yes. Very good. Because your speed is always going to be like a distance per a
Yeah.
time. Good. Okay, so now we have a few more problems. Let's see, 2 more word problems where we're going to create the chart ourselves. So we have the initial part and then the cool down part. So the initial and the cool down. And then give us the rates right away. So what rates did they give us?
You got 4 miles per hour.
I lied. I mean, okay, yeah, we can use that, but they give us the distance. I don't know why I said they gave us the rate.
Oh, you're talking about the distance.
Yeah, but I said the wrong word.
Miles.
So you answered me correctly. So yes, 26 miles initially, and then the cool down was
18.
18. I like to start with like the easiest part, if that makes sense. The part that we can like directly get, so we can be like, okay, we got 1 column down.
Yeah.
Okay. Find the speed. Okay, so if you want to let the variable be the rate, which is fine, then if the initial speed was, what letter do you want to use for the rate?
We'll just use X.
Okay, if the initial speed was X, what was the speed during the cool down period if he reduced his speed by 4 miles per hour?
So would you do 4 minus X?
Close, except think about it. Let's say let's say he was going 20 miles an hour. I guess that's pretty fast, but whatever. We're just making up numbers. What would be the new speed if it was?
So then you would do X minus 4.
Yes.
I always get that confused.
Try to do it. Do you notice that once I give you numbers, you can kind of make sense of it? So try to do that yourself in your head, right?
Okay.
Like, okay, If the one, just pick a, like I said, literally pick a random number. It doesn't matter if the number makes sense in the context of the problem. And then be like, okay, well, when I subtract 4, I certainly don't want to get a negative answer. And if I did 4 minus 20, that would be negative. So I know that's wrong. So, okay, it's the other way, right? So sometimes that'll work and you'd be able to do that on your own. Okay, if we know the distance and rate, how can we figure out the time?
So the time, would that be a 1 over x for the initial?
Okay, so what you have to do, if you recall, remember you only fill out 2 columns, which we've already done, and then you use them to figure out the 3rd column. So you go back to what we were saying a minute ago, that distance always equals rate times time, correct?
Mm-hmm.
So then how could you solve that for time? How could you get the time by itself?
You divide it.
You divide by r, right? So then time ends up equaling distance divided by rate.
6 over x, right?
So 26 over x. Good. And then the other spot?
18 over x minus 4.
Okay, so you're only ever filling in 2 columns for the distance, rate, and time, whatever 2 columns you can, and then use those 2 columns to come up with your 3rd column.
Okay.
Then go back to the problem to figure out the relationship. So in the last problem, it said something was 1 hour longer. Here, thank goodness, it actually says something even more helpful, which is what? What does the problem tell us about the time?
They took the same time.
Yes, which means we can do what with the 2 time expressions?
Can you turn this into like a proportion?
Yes.
Okay.
Because the same is another way of saying equal, right? So you can set them equal to each other. Exactly. And then you could absolutely solve it like a proportion, which is also nice, as you said. So what does that give you when you cross multiply?
All right, so we got 26x minus 104 equals 18x.
Okay.
So then I would subtract the 26. So you have like the negative 104 equals negative 8x. And then divide the negative 8. And that comes out to a positive 13.
If you look back at your chart, what does x represent?
The rate.
The rate of which one?
Of the initial.
Of the initial or the first portion. So that would be your first answer, 13. And then once again, this one's going to be miles per hour. Okay. And then for the cool down portion, how are you going to figure that out?
You would do the 13 minus 4.
Which would give you
9.
9. Good. So each problem is different, as you'll also see with the next problem, but there are also some similarities in these distance, rate, and time problems as well. So let's try the next one. We're going with the wind and against the wind. And we have distance, rate, time. So let's start with the easy part, which is the distance again. What is the distance we're traveling with the wind?
486.
And how about against the wind?
396.
Okay. Now for the rate, they tell us the rate in still air, but we also need to identify the rate of the wind, right? So if the rate in still air is 245, let's use X to represent the speed of the wind, okay, since that's what we're ultimately finding. So if you're going with the wind, does that mean you're going faster or slower?
Faster.
Faster. So what do you think we have to do with the X and the 245 if we're going with the wind?
You'd subtract the 245. Well, that's still air though. Wouldn't that be subtracting it?
So still air is like if there was no wind at all, the plane would be traveling 245 miles per hour.
Mm-hmm.
Right? But if you think of like pretend you're running instead of a plane, right? If you're running and the wind is like helping you, you're going to go fast.
Oh, you're going to add it.
You're actually going to add it. So you would take 245 and you would add X because the wind is actually causing you to go faster. Whereas if you're running into the wind or flying into the wind, that's when you're going to subtract. So you're going to take the 245, which is the initial speed, and subtract. Let's pretend the wind was 20 miles an hour. You would subtract that.
Okay.
Okay. How do we figure out the time if we have the distance and the rate already filled in on the chart?
You would divide it.
Yes, very good. So what would it be in the first time for with the wind?
It would be 486 over the 245 plus X.
So are you starting to see kind of like what I said, that there are some similarities to each problem, even though there's obviously differences as well, but this is one thing that they all have in common is that to figure out the time column, you're dividing the distance by the rate. So then the other one would be 396 over 245 minus X. Some big numbers here. What's the good news once again, just like the last problem?
You can set them both equal.
Because it says the same amount of time. Oh, and I already wrote over there, so we'll do this one here. Okay. 486 over 245 plus X equals 396. Imagine if you had to do this without a calculator.
Oh my, that would not be fun.
No, thank you, right? Thank goodness for calculators. I personally do not even want to multiply 486 by 245. Like no part of me would want to do that without a calculator. Okay. Can I? Yes. Can you? Yes. But why? Okay. So 486 times 245.
I got 119,070.
119070.
Yes.
119,070. Okay. Minus 486x equals, and then 240. Yeah, go ahead.
97,020 plus X.
396x. Okay, so now let's subtract, or which way did you do it? I can match you, it doesn't matter if you do
I would probably just subtract the 97,000.
Okay, that was my first instinct, but it doesn't matter. So I didn't want to mess you up if you had done it a different way. Okay, what does that give you when you subtract that?
22,050.
Good, that I can confirm. Okay, now what?
So add the 486 to the 396.
Which is?
486. 882.
Okay, I'm hoping this divides evenly.
And then you divide them. You get 25.
Okay, good. 25, and then once again, it was miles per hour. Okay, so other than the numbers being ridiculously large, any questions there?
No.
Okay.
Well, would you have to add to find the rate? Wasn't it to find the rate?
So they asked you for the speed of the wind,
The speed of the wind.
which
So-
was the x. But if they asked you for the rate with the wind, it would actually be
Oh.
like 270, or the rate
Okay.
against the wind, right? If you subtract 25, it would be 220. But they
Okay.
actually just asked you for the speed of the wind, so 25 is your final
Okay,
answer.
that was my question.
It would literally depend on what they asked there. So what I circled, if they asked for something different, then you might have an extra calculation at the end.
Okay.
Okay, so now we're going to do a few complex fractions, which are very well named, I like to say, because they are complex and they obviously are fractions. So there's a few ways you can do these. They normally teach you two different methods. The one works really well if you already have one fraction in the top and one fraction in the bottom, which is what we have here. So I'll go ahead and use the first method on this problem, which is to simply rewrite it as a multiplication problem, because like we talked about earlier, dividing is always the same as multiplying by the reciprocal. Okay, but this only works when you already have one fraction in the top and one fraction in the bottom. Okay, but when you do, it's really not that bad of a problem, because you're really just dividing, which is like multiplying by the reciprocal. So are you with me so far?
Yes.
Okay, now you can do what we did earlier. See if anything cancels. So do you see anything that cancels out?
Yes, the 4 and the 16.
So what does it become?
The 4 cancels out and the numerator is a 4.
Good, you divided each of them by 4, so this becomes a 1, which basically cancels out. Good. Okay, so then what is your final answer?
So it's x plus 2 over 5x minus 1.
What did you forget?
Oh, the 4. So I can distribute that though, can I? So
You
it'd be
can
4x.
distribute it, or leave it like this. So yeah, 4x plus 8, or you can just leave it like that.
Okay.
But you certainly need to include it there.
Okay.
Okay, so that's the best way to solve it when you just have one fraction in the top, one fraction in the bottom. However, sometimes you have multiple fractions in the top and multiple fractions in the bottom, like in the next problem. When that happens, I like to use the second method, which is to clear out everything by multiplying each term by the little LCD. So you want to look at all of your little fractions, which you have 4 of them, right? And look at their denominators and figure out what the LCD is. So you have x, x minus 1, x, and x minus 1. So what is your overall LCD for your 4 little denominators?
It would be x times x minus 1.
Good. Now I want to show you why this works, and then I'll kind of show you how I actually apply it. So you're really just multiplying top and bottom of the whole thing by x, x minus 1, which is mathematically valid, right? Because you're really just multiplying by 1, right? But what that happens when you distribute that is it's really like you're multiplying that to every single little fraction. But that's why it actually works. So I'm going to rewrite it, even though it's a pain. X minus 3 over x. And then that's going to get multiplied by x, x minus 1. Oh, I don't like, do you see how there's a minus, a negative 8?
Yeah.
I'm going to change that to plus 8 because there's no need to have a double negative if that's okay with you.
Okay.
Because that's just messy otherwise. But I'm just rewriting it and then multiplying each little fraction by x, x minus 1. Okay, so for the first little fraction, what cancels out?
The x.
Okay, so that leaves us with x minus 3 times x minus 1, which we're going to have to work out. Okay, what cancels out with the next fraction?
The x minus 1.
Which leaves us with?
8x.
Okay, what cancels out with the next one?
The x.
So we're going to have to multiply that out. And then what cancels out with the last one?
The x minus 1.
So now we're going to have to multiply out x plus 1. So this problem is a lot of work. Okay, so now we're going to FOIL. What do you get when you FOIL there?
You get x squared minus x minus 3x minus or plus 3.
Good. And then we'll bring down the plus 8x. Okay, and then in the denominator, what do you get when you FOIL that out?
The denominator is going to be x squared minus 1.
The middle terms cancel out. Good. And then when you distribute the x?
X squared plus x.
Okay, we're still not even close to being done. Okay, so combine like terms in your numerator. What does that give you?
You got x squared plus 4x plus 3.
And in your denominator?
You have a 2x squared plus x minus 1.
Good. How would you factor your numerator? Because we're not done yet, because we have to factor to see if the factors cancel out. So we have gotten rid of the complex fraction, to be clear, but we haven't necessarily simplified.
Okay, so you would do the FOIL thing.
So what are two numbers that
factor
multiply to 3 and add up to 4?
3 and 1.
Good. And then for the denominator, I'm guessing you're going to want to do trial and error. So we're going to have a 2x and an x, and then we have to have 1s. So the only thing you really have to experiment with is the signs. There's not really a lot of options, which is good.
Is it negative 1, 2x minus 1, and then x plus 1?
2x squared plus 2x minus x. Yep, very good. So does anything cancel out?
Yeah, the x plus 1.
Okay, so now we have x plus 3 over 2x minus 1. Can we simplify that further?
Nope.
No, so that is our answer. Very good. Okay, so why don't we try that same method on number 31? So if there's only 2 little fractions here, right? And you want to look at their denominators and you want to find the LCD. So what would be the LCD here?
X squared.
And this one I think works out a little bit better. Hopefully, we'll find out. Or at least it might not be as long. Okay, so what happens here? When you multiply by x squared and then divide by x, what happens?
So you're going to get a 3x.
Good. Plus
7x squared.
All over?
Over 9. A minus 49x squared.
Okay, we got rid of the complex fraction, but are we fully done with the problem?
No.
No, we have to check and see. We have to see if it can be simplified, right? So we have to factor the numerator and denominator and see if they have any common factors. It could be that they don't, but it also could be that they do, like in the last problem. So we have to check. So what is the GCF for the numerator?
X.
Which leaves us with?
3 plus 7x.
Good. And then what can we do to factor the denominator?
You can do a 3 minus 7x and a 3 plus 7x.
Good. So does anything cancel out?
Yep, the 3 plus 7x does.
So what is our answer?
It's x over 3 minus 7x.
Very good. So you're doing okay with complex fractions?
Yeah.
Awesome. Absolute value. Absolute value is the distance from 0, right? So we always define absolute value to be positive. So if you're talking about the absolute value of positive 4, it's going to equal positive 4, because if you think of a number line, I'll just draw it out real quick. -4, -3, -2, -1, 0, 1, 2, 3, 4. If we say the absolute value of 4, it's going to equal 4 because 4 is 4 hops away from 0, right? But if we say the absolute value of -4, how many hops away from 0 is -4?
It's still 4.
Still 4, right? So when you take the absolute value, you always get a positive answer because we always say that distance is positive. Okay?
Okay.
So what happens here when you solve an absolute value equation, as long as you have a positive number initially on the outside, so as long as you have the absolute value symbols equal to a positive number, then that means that whatever is inside the absolute value can either equal the positive number that you have on the outside, or it could actually equal the negative of that number, because when you go to take the absolute value, it would become positive anyway.
Okay.
So what two solutions does that give us here? And feel free to use a calculator.
So 3.6 and negative 3.6.
Yeah, so sometimes it works out that your answers are just the same number, positive and negative, but definitely not always, as you'll see in some of the other problems. But the reason that works is, let's check those answers. 2 times 3.6 is 7.2. The absolute value of 7.2 is 7.2, right? So we just confirmed that the first answer worked. 2 times negative 3.6 is negative 7.2, but the absolute value of negative 7.2 is still positive 7.2, right? So they both work. That's why you take whatever's inside the absolute value expression, as long as it equals a positive number originally, set it equal to that number or the negative of that number, and you'll get two solutions for the typical absolute value equation.
Okay.
Okay, as long as it equals a positive number on the outside. Okay, so what two equations could you set up here?
You would just pull out the 2x minus 1.
Yeah, do not change it, just pull it out. Good. Set it equal to what?
To the 15.
And then what would the other equation be?
You can do it to negative 15.
Exactly. Okay, and then solve each of these equations like normal. So what solution?
So
Go ahead.
it would be 8 and negative 8. Oh, no, it would not.
Not negative 8, so you have to actually work it out. So what would the negative answer be?
It would be negative 7.
Very good. Because negative 15 plus 1 is negative 14, which when you divide by 2 gives you negative 7. Okay.
All right.
Now, there's also some special cases. For number 34, the absolute value equals 0. So if you use the rule we've been doing where you set it equal to the positive number and then the negative of that number, that doesn't really make sense because -0 is just 0, right? So instead of there being two solutions here, there's only going to be one solution. Just take whatever's inside the absolute value and set it equal to 0. You can't create another equation because -0 is just 0.
Mhm.
Okay, so then how would you solve that? How would you get the y by itself?
You would just divide the 16.
So y would equal
0.
0. Good. Not very exciting, right? Okay. The first step to solving an absolute value equation is you have to get the absolute value expression by itself. So here, how could you get the absolute value of 3n plus 6 by itself? What do you need to move over or get out of the way?
You would subtract the 17.
Good. So what does that give us now? The absolute value of 3n plus 6 equals?
Is a -9.
Okay. So what do you notice about this? What's different about this compared to the other problems we've done so far?
It's a negative number.
Mhm.
It equals a negative number.
It equals a negative number when you take the absolute value. Is that going to happen?
Yes.
So if you take the absolute value of something,
Oh, no.
can you get a negative
It
answer?
equals a positive.
No, it's always going to
No.
equal positive. So anytime if the original equation with the absolute value still there equals a negative, you know that does not work. So your answer is actually no solution, or the empty set symbol that they have there.
Okay.
Okay. So let's check out number 36. What's going to be the answer to number 36?
No solution.
Why?
Because it's a -12.
Because it's a -12 that the absolute value has to equal, right? So when you're creating your two equations, you do create one positive, one negative, like back in number 33, right? But the original number had to be positive. That's the difference.
Okay.
Okay. So that is it for today. So let me go ahead and stop sharing. Stop the video.